Welcome back aspirants on MacTech 40, and today we will solve one question based on Kaplan Turbine, and this question has been asked on GATE 2020 morning session. Okay, so this is very basic question and lots of fundamental things are included. If you know, then it is very easy question, and if you don't know some fundamentals and some thumb rules, so it will be very difficult for you. Okay, so the question is, for a Kaplan turbine, axial flow turbine, it is a Kaplan turbine, the outlet blade velocity diagram at a section is shown in figure. Okay, so first of all, let me draw you the top view of the Kaplan turbine. This is the hub and these are the blade. This is just rough diagram for your understanding. So this is your hub diameter. Okay, and this will be your out to out diameter. Okay, so this is D1 or DB. Sorry, I'm writing here DH. It is equal to hub diameter, and capital D O, that is outer diameter with including blade. Okay, so now as the water flowing, if I draw on the front view, this is the hub and these are the blades like this. So water will be flow like this, strike on the axis parallel to the rotation, so that's why it is called axial flow. So the cross section area of the water flow through this section, it is I'm going to express by yellow lines. Okay, this is hatched portion is the portion where the flow is flowing. So the area of flow, that is area of flow, it is equal to pi by 4 outer diameter square minus hub diameter square. Okay, so this is the okay, so this is area of flow, it is pi by 4 outer diameter square minus hub square, because from the hub no water flow will take place. Okay, so this is the, sorry, yes, this is the area, yes, exactly. Okay, and now this is the velocity triangle. Here CF is equal to flow velocity. So flow velocity, this is CF, but what we are writing here, VF2, we are just used to write VF2, and 2 is for outlet section. Okay, and from this diagram we can assume that the flow is radial at exit. Okay, CB, that means blade velocity, or you can say that U2. Our notation is U2, and CR, relative velocity. Instead of CR we will write VR2 at outlet. Now the another data that is given is the diameter at this section is 3 meter. Okay, so this diagram that is given to us is at particular section, this because the hub diameter is 2 meter and tip diameter, that means outer diameter, is 4 meter. So this inner diameter is 2 meter and outer diameter is 4 meter. So this is at mean point the velocity triangle is given. Okay, now the flow rate of water is given 100 meter cube per second, and RPM is also given 300 RPM. We have to find the outlet blade angle in degrees, this angle. So now generally we are uh, giving notation at outlet condition, that means at the tip, but here it is at mean position, it has taken, it is given to take, so we will use this notation to as a at this mean position. Okay, so uh, you got idea about what is the hub diameter and this. So this angle beta, from this you can easily write that 10 beta, this is outlet blade angle, 10 beta is equal to what, VF2 divided by U2. Now U2 is equal to diameter, peripheral velocity. So at the hub point, like at the hub diameter, the velocity is the peripheral velocity is pi into diameter of hub dh n by 60. Okay, and at the tip the peripheral velocity is pi don by 60. So this is changing as the increase of the diameter, so this is not constant. But as you know, the characteristics of Kaplan turbine, that is the velocity of flow remains constant throughout. Velocity of flow will remain constant. So whatever it may be passing through hub or tip or any other point, the velocity of flow will remain same, and the relative velocity will also change. But here we are only concerned with this outlet blade angle, so no need to worry about this. Okay, so how to find? So take this as a equation number 1, 10 beta 2, say it as a equation number 1. Now we don't have vf2 or u2, so for that u2, that means instantaneous peripheral velocity at 3 meter. U2 in our case we can write as a pi dn by 60, that is pi d is the mean diameter, that is 3 meter, n is what, rpm is given 300 rpm here, divided by 60. So here you will get as a peripheral velocity 47.12 meter per second. Got it? Now what is the vf, velocity of flow? So flow velocity, as its name suggests, it will associated the mass flow rate. So mass flow rate we can write as a q is equal to area of the flow into velocity of the flow at outlet or at given point. Okay, now q is given to us 100 meter cube per second. Okay, area is what, pi by 4, outer diameter square, that is tip diameter square. I have explained you why, because the area, the annulus in which flow will occur at this yellow hatched lines, okay, not on hub. So this area will be pi by 4 outer diameter square minus hub diameter square. So outer diameter square minus hub diameter square into velocity of flow vf2. Now we have outer diameter as well as inner diameter, that is outer diameter, that is 4 meter, 4 square 16, minus hub diameter is what, 2 square 4 into vf2. So this will become 16 minus 4, 12, 12 by 4, that is 3. So that is, this term will become 100 is equal to 3 pi into vf2. So when you solve this, you will get as a velocity of flow vf2 as 10.6 meter per second. Now this is constant for all the cross section area, so this is the main concept here. Okay, main point that you have to remember, otherwise you will be get stuck. Okay, now we have both the value vf2 and u2, so just put this in equation 1. So we have 10 beta 2 is equal to vf2 by u2, vf2 by u2. So what is the vf2? The value of vf2 is, we just find out 10.61 or 10.61, you can write, and the peripheral velocity at this section 47.12 meter per second. So when you solve this in your calculator and take tan inverse, so you will get outlet blade angle is 12.6 degrees Celsius. Sorry, not Celsius, actually it's the habit of taking thermodynamics too much, so this is the side effect of that. So this is only 12.6 degree outlet blade angle, so this is the answer. So today this is the end of lecture, and hope you enjoy it. And if you like this video, just like and share with your friends also. So, and one more announcement, that is our MacTech 40 has a Telegram group. also. So if the join this, I have given the link in the description. When the members will be more than 50, so we will start anonymous quiz of static GK portion, so that will be help you in upcoming exam like Vizag Steel, NLC, SSCJE. Okay, the recently Oil India Limited also has given its vacancy. Okay, so this is all for all these exam, this will be helpful. Okay, UPPSC assistant engineer exam, that is recently postponed. Okay, so in this you will be very helpful for this. So thank you for watching this. So join this Telegram group. Okay, so tomorrow we will meet with another video. So till then, keep studying, stay focused.